Hello again. In this video, we're going to talk about differential equations. Now, there's actually an entire course on differential equations because there are so many different types of differential equations. But in this video, we're going to focus in on the most basic types of differential equations. So first of all, what is a differential equation? Well, essentially, a differential equation is simply an equation that happens to have the derivative of f in it. So for example, in this equation here, we have f prime of x is equal to 2x plus 1. So this is called a differential equation because it has f prime of x in it. Now to solve this differential equation, we have to figure out what f of x is. So we're looking for a function, f of x, whose derivative ends up being 2x plus 10. In other words, we're trying to find the antiderivatives of 2x plus 10. Which happens to be x squared plus 10x plus a constant. So notice that if you take the derivative of this function here, you get 2x plus 10. And so that's the solution to this differential equation. It's this function here, right? X squared plus 10x plus c. Okay, so let's look at another differential equation. This is probably the most basic kind of differential equation you can have. We're looking for some function whose derivative is equal to 0. So what's f of x? Well, f of x must be a constant. And that's because when we take the derivative of a constant, we get 0. Okay, so let's look at another example. Let's say f prime of x is equal to x squared minus 2x. So what is f of x? Well, again, we're looking for some function so that when we take the derivative of it, we end up with x squared minus 2x. So the way to solve these differential equations like this is to find the antiderivatives of this function here, right, f prime of x. So we need to find the antiderivatives of this function. Okay, now we can break this up across subtraction. And then we can pull out the constant here, the 2. And then we can use the power rule to find both of these antiderivatives. So the power rule says you add 1 to the exponent, and then you divide by that number. So the antiderivative of x squared is x cubed over 3. Okay, and then the antiderivative of this would be x squared over 2, and then times this constant. Now, of course, you get a plus c in both cases because you have two antiderivatives. So I'm going to call this one c1 and this one c2. Then, of course, those add up to another constant, which I'm just going to call c. And of course, these twos cancel right here, and you're left with x squared and then plus some constant. Okay, so this is our f of x. Now, if you wanted to check this, just take note of the fact that the derivative of this function would be equal to x squared minus 2x. Okay, so that's the solution to this differential equation. It's equal to this function. Now, sometimes you'll have what are called initial value problems. So basically, an initial value problem is a differential equation and an initial value for the function that you're trying to find. So in this case, we know that f of 1 is equal to 1/3. Okay, that's known as an initial value. Okay, now we're trying to find a function that satisfies this differential equation, but also satisfies the fact that when you plug a 1 into the function, you get a 1/3 out. Okay, well, we already know the function has to look like this. If it's going to satisfy this differential equation. And now we know that when we plug a 1 in for x, so let's plug a 1 in here, we know that we get a 1/3 out. And that way, once we have this, we can solve for what c is, the constant. Okay, so you can see, subtract 1/3 from both sides, and that leaves you with a 0 over here. And then a -1 plus a c, and then you just add 1 to both sides. And so c must be equal to 1. And so the only function that would satisfy this differential equation and this initial value requirement would be this function here. X cubed over 3 minus x squared plus c equal to 1, so plus 1. So notice the difference between part A and B. In part A, the solution to this differential equation is an entire family of functions that look like this, where c could be any constant. But for an initial value problem, there's only one function that works. So it's not a whole family of functions, right? This is the only function that satisfies this differential equation and this initial value requirement. Okay, so I hope you found this video helpful. Thank you for watching.